Alright, time for another DraftPhysics.com. DebatePhysics.com also. Video presentation. And so the debate has gotten better in the sense that people can be provoked, I guess, to deal with this subject if others chime in and, make the argument instead of me. But whatever, that's okay. I suppose. I mean, I hate to have to rely on the fact that somebody would nudge other people. I don't like encouraging nudging, but whatever. I guess it's part of the requirement that this take place. So there's been a few people that now and then have chimed in and forced people to deal with subjects, and so I have to say level 1 wizard did a very good job of provoking physicist Michael to actually deal with the subject. I suppose that I won't call them concessions, the statements by Piro, okay, although vacillating and mushy, also contributed to the fact that he has more aggressively responded, and so anyway, it's all good. But there's always a taint to anything positive, and the taint is he's claiming that my comment was somehow not on the subject of the video, when I think it's clear that the most important mistake you can make, the biggest error you can make in doing an experiment, is under-analyzing the experiment. That is, not understanding exactly how it works. So, I mean, we have cases where, Brozo has done experiments where he's proven, he proved it, that something with twice the velocity doesn't go twice as far in a frictionless environment. I mean, that's what he proved in his experiment, right? Now, what he proved is he can't launch things at the proper velocity. I mean, kind of obviously, that's what he actually proved. But because he underthought about the experiment and what the expected results would be, that is, that there's no theoretical possibility of any other result than twice the velocity, twice the distance, he claims he proved otherwise. I mean, that's the danger. And I would argue that this is exactly what happened to Leibniz. Leibniz published before Newton, so he didn't really know about this whole idea of connecting time to gravity. And the simple fact is he fell for the 4 times the height. He thought gravity was a per foot force. Okay, that's just not right. And so he drew his conclusions based on the idea that, yes, you can roll something and it'll roll twice as fast, 4 times the distance with only twice the velocity. And yes, things falling in gravity, the same thing happens. You want to go twice as fast, you have to go 4 times higher into the gravity. Now, it seems, like that's revealing the truth, when no, it's revealing just the circumstance that exists. And if it's a time-dependent force and your velocity is increasing as the force is affecting you, and you get to retain the force you've acquired, you can understand why it's 4 times. It's understandable. But the biggest mistake you can make is, to think you're actually testing something when you're not testing it. So, like Brozo, who thought he's testing how much energy something has by testing its velocity, he doesn't understand that you're not taking away the velocity, so you can't see how much momentum something has by throwing it. It's not going to show that in the sense that you're not extracting the energy. Alright, where rolling you are. These are all little subtleties, but they're important. But anyway, my statement was clearly on the subject. I tailored the comment to be on the subject. And I'm just pointing out that, yes, although not having your number 2 pencil ready when you're going for the test, and not having your glasses would be big mistakes when it's testing day, they're kind of minor mistakes if the test you're going in for is like 2 plus 2 or something. It's not a real test because you haven't understood what you went to the wrong room, to test for something completely different. Alright, so anyway, so he says finally here after they have some conversation with Puro about how levers don't really work and how they don't conserve energy and somehow blah 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 blah. So we'll get to that in this comment probably. Here's the situation for the two perspective as I see it, and please correct me if I'm misunderstanding your position. I don't want to strawman, but you don't mind insulting. I mean, you don't mind being patronizing and using rhetorical tools against other people by saying things like, well, he just flat denied my experiment, when no, I didn't. I explained why I think it's garbage, and I explained that if I reverse your experiment, it's not going to come out the way you made it come out going forward. In the sense that if you try to get a spring not to detect momentum, you're not going to succeed. All right. The way that you're trying to apply both conservation of momentum and Newton's laws. So again, this is more about how they're applying a law when they're just stating these circumstances exist. There's a certain consistency in these, okay, you can't call them laws, but in these tendencies. And there's absolutely nothing wrong with accepting their existence and then explaining how, well, in light of that tendency, how do you explain these results? So there's a tendency that you have to conserve momentum. So when you don't conserve it, then somebody can rightly point out, why didn't you conserve it? So if you're saying a lever doesn't conserve momentum, you have to explain, well, what's the way it can possibly not conserve it? Where can the momentum possibly go? Then the launch velocity of the 1/2 object would be twice the incoming velocity of the one mass velocity before it hit, and this would cause KE of the system to increase. So he's conceding the argument. So let me, sorry, I'm going to, make the video longer by explaining. Okay. And so hopefully, if physicist Michael's paying any attention, let's just draw it and explain that you have a lever, a simple device for converting momentums. I would argue that's what it does, and I could put a 2 mass here and I could put a 2 mass here, and I think we all have the expectation that if I throw this in with a force, okay, a force F, okay, I'm going to get force F out. Now what we don't know is how perfectly efficient is a lever. So like springs and like everything else, there's going to be some losses to some sort of frictions here or there, and some weight distributions, whatever you want to call it. So what do we get? 99% back? Do we get 95? So there'll be a number, whatever the percentage is. All right, and the catches is with this device. Okay, you can put the 2 mass one distance here, and I can put a 1 mass out here. Now I could put a quarter mass 4 units of distance, which I have done, and the lever will perfectly oscillate as stated. This 2 mass will move 1 unit of distance. The 1 mass here will move 2 units of distance in the same time, meaning it has twice the velocity. And theoretically, if I stop the lever, that is, it's at this midpoint, so it swings down, it's swinging back up, it's at this midpoint, and I stop the lever, this object will keep moving at its velocity, and this object would keep moving theoretically if we could, do it at the same time. So you can't really do it at the same time. You have to stop this one at a different time you stop that one. But either one of these, you stop the lever, okay, and this the idea is it's going to retain its velocity. It's not going to change its velocity. Something's not going to tragically happen to destroy that velocity. And so this one would leave with twice, okay, 2x the velocity that this one's going to leave at. Now, whether or not the momentum of the whole system has been conserved, I can't make the argument, but I would say why not would be the simple explanation. So that's the circumstance, that the lever considers this a 2 mass. The lever will move exactly the same as I pointed out. So if I put the 2 mass here, okay, the lever, this side of the lever can't tell the difference. The force comes in this way, it moves the lever. So if the 2 mass is there, it leaves at 1 unit of velocity. If the 1 mass is out here, it's going to leave at 2 units of velocity, and the whole lever, the stick, it's going to move exactly the same. It's going to consider this a 2 mass, and it's going to move exactly as it would if the 2 mass was here. By putting the 1 mass here, because it's twice the velocity and half the mass, so it's the same momentum, it's the same weight. This side can only see the weight. That's all it can see. The lever, the fulcrum, can only see the weight. So when I put a 1 mass, okay, twice the distance, it's seeing a 2 mass at half the distance, at that 1 unit of distance. It's not seeing anything different. It's seeing the same exact weight. So it's going to behave exactly as it would with the same weight. It's not going to behave any differently. So that's the logic anyway. Seems perfectly sensible. Now they won't draw this and explain how it's not sensible. How what I just said isn't sensible somehow. They won't explain how it's not a logical conclusion, that there's really no mechanism for this fulcrum or for this mass to see what's over here. It can only feel it as a weight. All it knows is there's 9 pounds, 9 pounds, 9 pounds. That's all. It can just feel it as a weight. There's nothing else. All right. So that's the subject. And obviously if this happened, okay, if I were able to put the force in with the heavy mass, I'll have a certain momentum. And the truth is I'll end up creating free kinetic energy on the other side, because I will conserve the momentum in a lighter object, which means I'm going to increase the velocity, which with their squared term means I've increased the energy. And so the simple act of pushing the 2 down and pushing the 1 mass up would create free energy. So obviously the simple truth is, if it does this simple thing, it proves that the kinetic energy theory has a flaw, a rather egregious one. Alright, I think that's enough of a context. Continuing. Alright, so he's conceded that the increase in kinetic energy would be unviable. I agree that if the launch velocity of the half-mass object was twice the incoming velocity of the 1-mass object, this would violate conservation of energy. Right, it would be conservation of momentum, so clearly it's not violation of conservation of energy in any other notion than kinetic energy. So this is where they've stolen the term energy and said it means kinetic energy. It doesn't mean momentum ever in their Bible. And so this is how they use the rhetoric. Now I do exactly the same thing. I very often will say conservation of energy when I mean conservation of momentum, because they don't believe momentum is energy. Alright. But the launch velocity won't be twice the initial. And by what logic won't it? That's the point of the argument. Is, could you explain ahead of time even what your theory is of how it doesn't? How does this side of the lever know that this other 1 mass is not a 2 mass 1 distance? How can it really tell the difference? They weigh the same. How does it know that, oh, one of those weights is a lie? How does it know that? How is that signal sent anywhere? How could it be possible for this side of the lever to know it's being fooled? Okay, it'll be significantly less. So this is where you should say it'll be 1.4. So instead of going twice the velocity, it will be obligated to only go a 0.4 increase. So this is the same argument that's been used against the bowling analogy, right? Where you just point out, it's not even an analogy, it's a perfect example, frankly. No professional bowler uses a lighter bowling ball. Yet physics says the 8-pound ball going twice as fast will knock down twice as many pins. It has twice as much force and energy stored in it in scalar power. Okay, so it has all this extra power, and yet no professional can find that power. And they go with the more stable 16-pound ball with the same momentum as the 8-pound ball, frankly. Because, yes, it's the same momentum, and they get a more stable weight of ball, so it works better. And they can't take advantage. The point is that they can't find this extra energy that the 8-pound ball has. And the argument is made that somehow some bowler can't throw the 8-pound ball twice as fast. He can only throw it 1.4 faster. not 0.6 faster or 0.7 faster or 0.8 faster, no, only 0.4 faster. So it's an incredible disability. So they're saying that if you could throw a shot put, 50 feet, and I made the shot put half as light, you couldn't throw it 100 feet. That's sort of their argument. All right, here are the main issues. Well, this would be 0.4, so you'd only be able to throw it like 65 feet or something. Here are the main issues that I can see with your analysis. So this is where I did the drawing just to point out how simple this is and how they're going to talk about stuff that doesn't make any sense in the sense of, some sort of weird problem that takes place. So I'm just saying, if you concede that the 2 mass and the 2 mass on a lever will conserve the momentum or energy or whatever you want to call it, that it'll be conserved, that the force going in will be the same as the force going out except in the opposite direction. And obviously it can't mean anything, the opposite direction, right? You're not paying for it in some way. All right. I mean, you're not putting energy in to cause the reversal in the direction. The reversal in the direction is clearly in this closed system for free. You're not going to pay for it in any way. All right. Conservation of linear momentum doesn't work here. Okay. So he's just making these as statements. He has no evidence it doesn't work, but he's just saying it. Because total momentum is only conserved if there are no external forces acting on the system. So there is no external force except the fulcrum, you could argue. And what is it capable of doing exactly? I mean, what exactly, like if I put a scale underneath the fulcrum, is it going to really register that there's a whole bunch going on? I don't think it will, but whatever. It certainly can't add energy. So, all right. When the 1 mass hits, there will be a force at the pivot point stopping the entire lever from being knocked to the side. So when the 1 mass hits, in this case 2 mass, okay, because we're not using half and 1, I'm using 2 and 1. So a little bit of a, I think this is simpler, but whatever. Okay, so he says when the 2 mass hits, there'll be a force at the pivot point, so somewhere in this fulcrum, stopping the entire lever from being knocked to the side. So there's going to be resistance because there's a weight. If there's no weight, then the lever just swings, because we're made a very light lever and it's really not going to be an issue. Pushing the lever will be a minor amount of energy. So the lever will just swing all the way down and the 2 mass will just continue on its way, having disposed of the impediment in its way. But if there's a mass on there, then it's going to have to deal with the fact that now it's hitting something, essentially. You're making the 2 mass now hit this other mass through the lever. So it's just like the string tied to the weight. The weight is doing the work, all right, and you're conveying it through the string. Well, we're conveying it through this lever, and the neat trick it can do is this direction change. All right. We can also show this since momentum is a vector quantity, so direction matters. So obviously it doesn't matter. I'm just going to argue that if I have a 2 mass and a 2 mass, direction doesn't matter. There's no way you subtract this and say there's no momentum in the universe now because I've disposed of it because I have a equal and opposite reaction. No. It's clearly the energy goes in, the ground converts it into an opposite reaction. And it does it theoretically for free from any notice that we can see. Alright, we can also show this since momentum is a vector quantity, no direction matters. So direction matters. The fact that the direction of the 1 mass object and the 1/2 object are going in different directions, so the fact that if I did the 2 and the 2, so again, if we just make it the same mass at the same distance, I don't think you're going to argue the lever fails. So this direction argument can't mean anything. It means that it cannot have the same momentum. So he's basically saying that the lever doesn't work in this simple circumstance. that pushing down on one side does not lift the other side with the same force, that somehow the force breaks down. So if I just pushed on a lever, well, I mean, we all have some example of that, right, where we're pushing on one side and then we push down on the other side, and there's no evidence that, oh wow, the whole thing fails to work. You know, I mean, water pumps, oil pumps, lots of things do this simple leverage argument where you just push up on one side and it pushes down in the opposite direction. They're using it for a purpose. It works. So he's saying it doesn't work when clearly it does work. So, you know, he's wrong. Okay, now you can't tell these people they're wrong, but yeah, you're wrong to say that, okay, that different directions means they cannot have the same momentum, because trains use it, you know, all kinds of things use this idea of a rod pushing in one direction to cause motion in the opposite direction. I'll be setting up a demo of this specifically in the next couple of weeks for a different, simpler system. Well, I don't know how you get any simpler. Okay, so that's, you know, that's kind of a funny line, right? But it should still highlight the issue. So whatever he's doing with these demos, again, I'm going to argue that these are classic, out of the textbook demos, and frankly, that's what's wrong with physics, is it contrives experiments to try to highlight what it's saying, and it ignores the volume of information, just like he's ignoring that I can take a lever and put a 2-mass and a 2-mass, and it works just fine. Alright, the balance of two, his second argument. The balance of forces where you're trying to use 1/2 at twice the distance only works if the lever is in balance. So again, there's no reason to believe that's true, that somehow, as it's the weight's pushing, that somehow it doesn't push right as it pushes further, somehow it gets disconnected. Let's understand this, the simple argument I'm making. You probably don't even need to see this text, frankly, but you know, well, I probably could get that a lot better. Anyway, is that the key to the lever's function, the reason why this whole thing works so well, is that it's matching, okay, the force at this location to the acceleration at this location. So it's doing what the Newton's cradle can't do. It's creating a consistency between the velocities. So if I try to do this with a Newton's cradle, it won't work. Okay, I can't, more specifically in the other direction, but I can't get all this thing's energy into this little object. Oh, that didn't work at all. Yeah, I guess it was better the way it was. Anyway, I can't get the energy from this into this because the velocities don't match. Alright, I'm not going to decelerate this at the same rate. I'm going to have to accelerate that to make it go twice the speed. I can't make it go twice the speed. I can only push it at the speed I'm going, so I'm not going to be able to increase its speed enough. And the lever fixes that because it takes this slow deceleration here and it converts it into the faster acceleration on this side, because the half mass can now do the faster acceleration. So as this decelerates, this accelerates, and it's exactly the same. Again, if I put the 2 mass back here, the lever, this part of the bar, is going to move exactly the same here as it moved here. It's not going to be able to tell the difference. It's going to make the same motion, okay, in space as if the 1 mass is here. The lever moves exactly the same. This arm moves exactly the same whether I have a 1/4 mass or an 1/8 mass or a 1/16 mass. No matter how small a mass I put on the other side, this side is going to move exactly the same as long as I match the location precisely. So as long as I'm giving this the right velocity. Now if I move it in a little bit, then I'm going to get into trouble, okay, because now this and this aren't going to match in terms of the conversion. And if I go further out, it's going to be obviously heavier, so it's going to be like this will bounce because it won't be able to get all the energy in. But theoretically, just as if I put a 2 mass here and a 2 mass here, it's going to duplicate the Newton's cradle in the perfect circumstance, right, where the masses are the same and the energy just completely flows into the other object. Well, the same thing is going to happen. And when I put the 1 mass out here, to the system. The system is going to do the velocity conversion, the higher acceleration and the low deceleration. It's going to match those two. So you just have to match the arrows to be exactly half or 1/8 or whatever the amount is. And as long as it's a full wavelength, you have no problem. The lever won't be able to tell the difference. That's the logical argument. Alright, works if the lever is in balance. During the impact, the lever is specifically not in balance. So this balance argument doesn't really mean anything, again, just because it will duplicate the Newton's cradle. It will take the force coming in and give it to the other object. All the energy will go from the object on one side of the lever into the object on the other side of the lever. So we can't generally use the balance that you're assuming. So, says you, okay, with really no explanation for why it fails to work. The details depend on the properties of the lever, the size and the mass, if it has any flux, things like that. Again, you can eliminate all those by just doing the first experiment. Just have a 2 mass and a 2 mass and see if you can make the lever conserve the momentum. And if you can, then you can do your experiments. Alright, so how do we determine which of us, if either, is correct? Yeah, we just do the simplest experiment you can almost imagine, and you're saying, gee, such a simple experiment, in 350 years, no scientist has done it. So that's, that's the statement about the credibility of your science. You're saying we have all of this respect for the scientific method, and yet the facts don't indicate any respect for the scientific method. Where you sit there and you propose your theory and then you say, well, look, this simple lever experiment will show how it's true. So why don't you do the lever experiment and show how it's true? Alright, just setting up an arbitrary lever. So that's what you've suggested in your videos, is that we do a bunch of DIY experiments and just slop something together and prove physics. You've said it to me. You said in my cruddy little basement I live in that I'm supposed to be doing high science, proving scientific theories. No, I'm not supposed to be doing that. And doing a launch would show that the launch velocity of the half-mass object is not twice the incoming m velocity would be fairly straightforward. Yeah, that would be. So it seems like it's all straightforward. Now, Brozo did do this. I mean, he did do it with a spring, so he had a constant force to push the objects, and he got results of 19 and 11, which are almost 2 to 1. But anyway. But the details and being able to predict what the launch velocity actually is a lot more complicated and depends on the details of the setup. Well, by your theory, it has to be something like 1.4. Yeah, so you have to kill an awful lot of the momentum. You have to destroy the momentum to conserve the KE. It's a simple truth that these two formulas have nothing, they are not in any way compatible. And in any circumstance where you change the mass and you're trying to exchange energy, one of them has to be right and one of them has to be useless nonsense. Alright, as I said, I don't want to go through the work of setting up and doing the experiment and after get objections to the setup. Well, that's just part of science, frankly. I mean, people are allowed to object. Now, I object to the experiment where you basically made a spring not weigh things. That somehow the spring failed to properly weigh things. Okay, and it made heavy things weigh the same as light things. I'm saying that something's wrong with your setup because, frankly, the scale can't do that. Something that weighs 10 pounds can't weigh 5 pounds. And rejection of the results. So I'd like to get recommendations on what setup would satisfy any criterion you have. So that's sort of what this is a beginning of, is my list of criterion. So my first criterion is that you do this simple test with a 2 mass and a 1 mass and a 1 mass at the same distance. And first you establish that your lever is capable of conserving the momentum. And once you've established it's capable of conserving it, then we can do the other experiments. It says chat chains are generally not a great way to have clear discussion. Well, if you ask a direct question, it's pretty, it's useful if people gave direct answers, but they really don't. I've asked direct questions and I don't get anything like a direct answer. Too much opportunity to misinterpret and talk past each other. Me. Part of me says it's all in text there so you can see it. If somebody's evading the question, it's going to be kind of obvious. But anyway, I'm not a big fan of typing, so yes, I'm all for talking about it. It's the interaction part that I think is more useful, in that you can repeat the question when they don't answer it. So I'm thinking of setting up a live stream or even a Zoom call. Okay. If it's a live stream, yeah, I'm not going to, sorry, I'm not too interested, because I'm not going to be able to type, my conversation. Yeah, no, I don't really want to do that. For live audio responses, that would be good, in a couple of weeks, to discuss the experiment and get specific recommendations. Alright, so one specific recommendation is do it horizontally. So in overview, it would look like this. So we'll get gravity out of it, and as much as possible, and then we just have to worry about moving things, which is the other part that's obviously has there's some nuance to it, since every one of the do-it-yourselfers seem to fail to be able to get velocities correct. Alright, I'm thinking of setting up, okay, we did that a couple weeks, I'm thinking July 29th. Well, that's rather specific. The next couple of weeks are very busy for me, and I want to get that momentum demo done first to address point 1 above. So whatever that momentum demo is, I'm obviously probably going to have some problems with that experiment. But anyway, if this is of interest to you or anyone else who has been following this chain, I'll try to figure out and post details in the next couple of days. So yes, while planning for the 2 weeks or more from now is a little bit dicey, but whatever, who cares? Fine. So this is all very positive. He's going to do the experiment. It's basically decisive, in the sense that if it's true, okay, that momentum is conserved by a lever, then it's the end of the kinetic energy theory as being viable science, because it'll basically turn the lever into a free energy device, and we all kind of know there's no free energy. There's very cheap energy, but there's no free energy, and there's no mechanism in the lever itself. And it would obviously be something you could just magnify. You just lever after lever after lever, just make a system of levers, and it would be self-perpetuating and it would be a turbine spinning with no fuel, essentially, because it's keeps making more energy. The more you drop on it, the more free energy it makes on the other side. So yes, it can't work. So if it conserves momentum, it proves the case. And if by some miracle, frankly, I can't imagine. So I wish somebody would theoretically explain to me how you prevent the half mass from going twice the velocity, and instead it only goes 0.4 faster, only 0.4. Losing 0.6, losing a huge amount of velocity. So, they have to really kill an awful lot of velocity to make the kinetic energy theory viable. And again, the smaller I make the object, the more preposterous the amount of, momentum they have to destroy. Alright. So, so that's all positive. So, thank you. I appreciate it. And good job, level 1 wizard guy, for forcing the attention to be paid. Alright, so I guess I'll do, there's one other little thread. These people are just so, they're just so obnoxious and dishonest. So there is a thread on this Letska video. I just feel an obligation to respond to the lies in here. Defend myself against them. Jerry Hall, who's, lied in the past, I had to block him because he's a liar. Just these people are just despicable. So just recognize that he's going to say stuff here that is just idiotic. So he says, at least DS admitted that velocity is a vector. Now, the entire time I have been alive on Earth, I never even imagined what a scalar would be. So I don't even know what a scalar is. It doesn't mean anything to me. I have no conception of anything but vectors. So since I was a kid, I believed that there are rays of light coming off the sun. I believed that things move in straight lines unless something forces them to be bent. So nothing draws a circle. Even since I was, you could say I was in high school when, and in algebra, and we're doing geometry, and I had already thought about the fact that a circle is never a circle. That when they're doing pi and all this stuff, it's because the circle isn't really a circle. It's a bunch of little straight lines. That the real universe is a least, and we've blended all the leasing out, but the real universe is like text when you blow it up. It's a bunch of straight lines, okay? So I've always believed in vectors. I've always thought all energy moved as vectors. There's never been a single video or any moment where I've ever made any concession to anything traveling a crooked line or doing any of that kind of crap without a direct straight line cause. Everything is banging particles and things banging into each other and either being absorbed or reflected. So I've never suggested anything else but that velocity is a vector. I've never said anything that could be perverted into thinking I've ever suggested energy as in any other form than a vector. So it's just a despicable lie to imply that anything has changed. It means momentum must also be a vector. Yeah, of course. I don't understand. Yes, it's a mass moving in a direction through space. Again, I've never made the argument that things orbit in a circle. I've made the argument that no, they're going this way and then they're going that way, and the two ways bang into each other. The math is done by the masses, but the forces aren't any kind of other. The forces aren't bent. It's a straight line force of gravity. It's rays of gravity. The product of the scalar and the vector is a vector. So he says. I mean, that has nothing to do with me. That's your wacky verbiage. But he has denied several times that momentum is a vector. So it's just a complete, absolute lie. I have never, ever, ever said anything to indicate that momentum is anything other than the velocity portion of vector. Ever. There's no way. I don't even know how he comes up with this nonsense. Where could you possibly pervert anything I've ever said into conceding that any portion of momentum can be in any other form than motion in a straight line? I also can't make up his mind if momentum is conserved or not. So again, another insane lie. I mean, where in any of these videos have I ever said you could destroy energy? I have never said that. I've never implied it. I've said you can either store it, you can trap things in circles. You could, circles that aren't really circles, by the way. Just going back and forth, trapped in a box like a pressurized tank of gas. I have never, ever, ever, ever said anything okay, about how you could destroy the forces. I've talked about Descartes and the simple idea that the motion just moves from thing to thing. I mean, it's amazing that these people get away with this crap. So, I mean, you know, Leska guy, I'm going to blame you, all right? This is your comment section, and this fucker, okay, is overtly lying about what I've said and what I believe. I mean, you know that's a lie, right? You know, you've seen enough of my videos to know I've never said any such thing as momentum doesn't have to be conserved. I mean, all mass velocity relationship has to be conserved. You can't get rid of mass and you can't get rid of the velocity portion. Both portions are real things. The force is causing the velocity and the mass is the mass. You can't destroy the mass and you can't get rid of the fact that the force is at this time doing this thing, and the force will just keep moving through the universe. Difficult to debate with someone who doesn't stick to his own opinions. So it's just such an egregious lie. And it's just the fact that these fuckers get away with this crap. This is slander. I'm sorry, this is slander, okay? You have no good reason to believe this, and you have no good reason to state it. It's just absolute lying. Newton's third law means that force acts as a pair. So, no, it doesn't. Third law means if you give away your money, you are poor. Yeah, that's what happens. Oh, there is no reaction. I don't even know what he means by it. There is no reaction. But whatever. I mean, that's his interpretation. Alright, so Mindless says, it's not an emission of anything. It's not an emission, okay? And it's one of the most important subjects that we're discussing is conservation of the idea of movement in the universe. And clearly I've always advocated that the motion in the universe is conserved. Because it doesn't mean anything. Don't take anything he says too seriously. So again, he's just implying that somehow this is true, that somehow I have changed from some sort of scalar perception of the universe to some sort of vector perspective, when no, I can honestly say for my entire time here on Earth, I never conceived of scalar energy. Alright, he is utterly and completely inconsistent. So again, it's just such a lie. I mean, just egregious. It's disgusting that these people get away with this, and the little opposition people don't even clean this up. I mean, this is soldiers shooting. You know, you're shooting your own cause here, because they really are demonstrating why the science is bad. Is because these people will lie. They just couldn't care less about the actual facts. Okay, oftentimes he keeps saying all energy has a direction. Yeah, every single time I talk about energy, I talk about it as rays of energy, frankly. Do you think a train moving down a track isn't moving along the tracks? Yeah, duh. I made the example that you're saying it has some sort of kinetic energy, this magical kinetic energy, and we're really not talking about its nuclear, you know, the capacity to blow it up in a chain reaction. We're not talking about blowing up the energy in the atoms. We're talking about its motion energy. I mean, that's what kinetic energy is. It's motion energy. And yet they're saying it doesn't know where it's going. The energy doesn't have a direction. I mean, it doesn't make any... They're the ones not making, obviously, any sense. How can you say these things and say you're being consistent to reason? And other times he says all the talk is nonsense. All this talk is nonsense. What are you talking about? So again, just lying. Okay, if there is a bullet going this way and another bullet going the other way, the other bullet won't undo the first bullet. Yeah, obviously. Now, I've obviously made it clear, I can say again, quite honestly, I never conceived in my life of anything called unenergy. Alright, some kind of energy that undoes other energy. Never a conception I played with. Antimatter. Never believed anything called an antimatter or an anti-force. There's no such thing in my conception of reality. as any such crap, frankly. I have no good reason to believe it, and it, on its face, is nonsensical. So, in DraftScience versus Physics with Flawed Experiment, blah, 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 at 5:15, he claims he never argued it's anything other than a vector, and he never changed his opinion, and people keep lying that he did. And that's exactly true. So, the accusation's been made. Mindless is engaging in the argument as if this actually happened. But then he says, what do you make of this? So, yeah, the very fact is they have no evidence for this whole conversation, and yet they're having the conversation anyway. All right, and so let's see what Jerry says to that. Yes, I saw that. Funny guy, isn't it? So again, they'll never find a quote of me ever talking about scalars in any kind of way other than what the fuck is a scalar? You know, I've never believed anything in the universe isn't caught up in, it's just straight lines banging into each other. That's what I've argued. Okay, I've lost count of how many times he has used the word vector. So this is the same asshole who just said I somehow didn't know momentum was a vector. And yet I've lost count how many times he has used the word vector, CR, whatever that means, and said that energy can't cancel each other out. Yeah, I'm saying you can't have unenergy. Clearly I'm arguing that if an explosion takes place, there's no unenergy because the explosion makes stuff go in all directions and it cancels out. I'm clearly saying that no, there's a whole bunch of energy now free in the universe. You've just released a whole bunch of little bits of energy. And this way didn't cancel that way. And there's not zero momentum in the universe because these cancel out. I'm saying your moronic, idiotic, preposterous theory that there's negative energy is fucking idiotic. Especially negative momentum. I can't believe this idiot thinks he has a right to say I didn't believe in vectors because I don't believe that there's unenergy or anti-energy or however you want to describe it, negative energy, or that momentum is like 98% conserved and the rest turned into heat. Well, I've clearly stated that heat is energy, so there's just no point in saying that. 98% stays in the straight line that you want your laser beam to go in a straight line. Well, if you shoot your laser through some water molecules, then you'll end up losing some percentage of your photons. It doesn't mean the photons are gone. It means they're going someplace else because they hit something. Oh, God, it's just so bad. All right, 88% is conserved and the rest is turned to heat, sound, etc. So I don't even understand, or that momentum is like, I just don't even understand why somebody would disagree that that's what happens to systems. That, you know, a stream loses some of its momentum to the rocks it's moving and the other stuff that moves in the stream. That to move those objects, the stream of water had to give away some of its energy. It has to come from the momentum, is his argument. It has to come from the momentum, is his argument. I'm saying that if two things are flying off, they have real energy, and whatever caused that to happen has to have enough momentum in it to cause both of those actions. The two actions don't cancel each other. At least two videos where he makes this statement, which is brave, and I'm not sure if he believes it himself. So I don't even understand what the fuck you're talking about. I mean, you're so irrational. So I guess that's what he was going to rely on in court, is to say, well, I'm too retarded. I mean, I don't know what the hell I'm saying. So yeah, that sounds like a lie when I said these direct accusations. That sounds like I was lying. But, I can't tell the difference because he's too fucking retarded. So then he says again, but I'm happy we are getting somewhere. I mean, this is such a joke. It's hilarious. You're the ones who don't believe momentum is a vector, in the sense that you believe in scalar energy, whatever the fuck that is. Okay, is a step in the right direction. I mean, just amazing nonsense. You can't accept the existence of momentum if you're going to defend kinetic energy. As I've pointed out, they're not compatible theories. You can't conserve both. Oh, too stupid. Then Mindless says, I only wish I could agree, but I am fully convinced that vocabulary means nothing to him. So again, where do you get any honest belief? Where can you say you're fully convinced by what? What? So there's nothing honest in any of this crap. And he fundamentally just does not care. So again, care about what? Where am I showing some lack of care? I explicitly talk about why I believe what I believe. I explicitly explain it in detail why I believe it. And you counter it with nothing. Alright, what you think is vector doesn't mean the same vector to him. What it doesn't mean is vector to me means arrow in a direction. Okay, a line, an intensity in a direction. That's a vector. What I don't believe is in anti-vectors. I don't believe you can undo this with that. Okay, I'm extremely sure of that. So, whatever. So Jerry says, probably he is winning arguments according to himself. I'm just saying in the past, okay, my record is pretty good, okay, in making assertions and then watching the other side wither and die, okay, because my arguments are better. I've made me think about what's important. Politicians are good at winning arguments. So he says that anytime somebody wins an argument, they're a politician. So that's easy, right? You can do that to any video of anyone who ever won an argument and just say, well, liars always win. I mean, what a pile of mush. Does that mean they tell the truth? So all of this truth argument, I'm just saying, of all the dumbass accusations a moron could make against me, isn't this proof that they have no argument to make? They can't deal with my physics drawings. They won't draw a lever. They won't draw gears. They won't draw hydraulics. They won't explain how their system works as a counter argument to anything I explicitly draw and explicitly state. And instead they'll play this game that I'm lying about something, that somehow I'm being dishonest, when everything I'm doing is right here in front of you. What's dishonest about me recognizing that, well, how does the lever, or how does the weight over here know whether I have a 2 mass here or a 1 mass there? Because they weigh the same, you know. You push on the lever that weighs the same. How does it know that it's not really 9 pounds? Alright, is it more important to win an argument than to be honest? So again, the accusation is somehow I have dishonestly reported or dishonestly stated or dishonestly explained. That I'm being dishonest when I state that, you know, Eddington really did write in his journal, I would not stake my life on these results. He actually did write in his journal, I was expecting 10,000 stars per slide and I got 1,000. Those were things that actually happened. Those are actual correct reports. I reported that Madame Chartelet, okay, the person who started this cult, restarted the cult, the Leibnizian cult, was tutored by a Leibnizian. Okay, she never went to real school. She just went to tutors, and she was tutored on physics by a Leibnizian. I don't think, and she was sued, by the way, for stealing the Leibnizian rhetoric. I don't think it's the same thing. So he doesn't, you know, again, the accusation is somehow that I am being dishonest, and somehow I win arguments by being dishonest. Okay. Wonderful when honesty and rhetorical skill is united, but that's not always the case. So again, just another crappy slight that somehow I have used some non-honest rhetorical arguments. I mean, where exactly can you show an example of my non-honest rhetorical arguments? You liar. You fucking liar. I mean, that's all they got. So why are they coming to this argument about how a lever works, right, with all these lies? Why is this necessary on their part? Oh, that's right, because they don't have an argument. They can't counter what I say and why I say it makes logical sense. Okay. They really do know that if I shoot a bullet this way, it's not going to undo the bullet going that way. They know that's the truth. Oh, but god damn, it's just so obnoxious to be lied about. But it's just part of, fake news, fake world bullshit. They're the shyster politicians, attempting to smear and discredit their opponents with crap, absolute crap. He's fat. Yeah. Just such cheap tactic. Cheap. Really cheap. Cheap like a Brozo song. Anyway, I'll take a pause and see if there's anything to add. Alright, so we'll call that a video, and we'll look forward to, anticipation. We're going to have to just wait for it. The new version of the lever experiment. But we'll see how it's done, and we'll see how open he is to suggestions regarding creating the velocities and all that. I've suggested using pendulums, because you can sort of reliably measure the velocity based on the period, so you can just swing the pendulum and just make sure you get the right velocity from the right height, you have a quick release and all of that crap, and it shouldn't be a problem. So we'll see what happens. And just as physicist Michael says, well, if the experiment proves it, they have to accept the proof. Well, if the experiment proves it, are you willing to concede then that all of physics is bullshit, pretty much? I mean, 90% of physics is based on 1/2 mv squared, and 1/2 mv squared will be proven to be nonsense, and therefore you have to account for that and recognize that 90% of physics is a religion and fable and nonsense. Yeah. Okay. Are you going to be willing to do that? That the past 70 years worth of physics is really all just garbage. The creation of all those particles, the antimatter, all of it has to go, because all of it is a consequence of this stupid formula. Alright, anyway. Till the next time and such and so forth and whatnot.